Welcome back everyone to my channel Maths by Gurpreet Sekho. Now we are ready to finish our chapter Lines and Angles, chapter number 6 of ninth class with the remaining exercise 6.3. There are only two basic theorems which are being used in this exercise and only two examples are there. So we'll be able to finish the whole exercise in this only video. So stay tuned to learn all of the concepts which will be used in the exercise 6.3. And if you are new to my channel, do subscribe my channel to get the new updates regarding the syllabus of mathematics from classes 9th to 12th, and that would be very great if you like my video as well as share if you like my work. So let's start. In exercise 6.3 there are two theorems which are very basic theorems, and let's read the statement of theorem 6.7. It's saying that the sum of the angles of a triangle is 180 degree. It's very basic theorem and it's actually already taught to most of the students in class 6th or class 7th, but I will surely help you in revising the theorem. So firstly, suppose a triangle. Consider a triangle ABC and consider the angles as small a, small b and small c. So according to theorem 6.7, sum of the angles of a triangle. Now what are the angles of this triangle? Angle A plus angle B plus angle C is equals to 180 degree. That is what actually theorem 6.7 is stating. Okay, there is no proof of this theorem, you just have to learn this result directly. Okay, so you can also write angle ABC plus angle BCA plus angle CAB is equals to 180 degree in any way. Now what's theorem 6.8 is stating? It's stating that if a side of triangle is produced, so firstly understand this portion. Consider a triangle. The triangle, let it be ABC, and if a side of a triangle is produced means it is increased along its length. So let's produce the side BC of triangle and let this portion be E. So CE is the produced portion. Now we have produced a side of the triangle. If a side of the triangle is produced, then the exterior angles so formed. So let's form the angles. For example, angle A, angle B, and the exterior angle will be this angle. For example, it's the angle D and this one is C. The exterior angle so formed means after producing the length we have formed an exterior angle that will be equal to the sum of two interior opposite angles. Now according to theorem 6.8, angle D will be equal to sum of two interior opposite angles. Now there are three interior angles, but we have to only select two, which are those that are opposite angles, that are opposite to D. So opposite to D there are two angles A and B. So angle D will be equal to the sum of angle A and angle B. If you are unable to understand the concept of this thing, just replay the video and just go few minutes before when I started explaining theorem 6.8, then you will be surely understanding this theorem. So watch this video again and again to understand this concept because it's very much important. So it's simple. External angle will be equal to sum of two interior opposite angles. Don't add A and C by mistake, don't add B and C by mistake, just add the opposite angles which are opposite to the external formed angle. So these were two theorems which will be used in doing sums and examples of this exercise. Let's start with the example 7. I have drawn the diagram already and it's already given in your book, so don't worry about drawing it again. In figure, QT is given that it's perpendicular to PR. QT is perpendicular to PR, it's given already. TQR is 40 degree and SPR is 30 degree. We have to find X and Y, the unknown figures of course. Okay, so now let's concentrate on these two theorems which we have just studied, and we'll be only using these, so don't worry about the corresponding angles, axioms and other axioms that we have studied in the previous exercises. We will only be applying these two theorems because these are only dealing with triangles, no parallel lines, no transversals at all. Okay, so firstly take the triangle that is TQR because we have to find X, and if we want to find X we cannot take the triangle PRS, because there is the third side isn't given, so that's why we will take the triangle in which two sides are given and we only have to find the third one. So in triangle TQR, now omit this line, PS, omit this line. So in TQR, what are three angles? 90 degree, 40 and X. 90 degree plus 40 degree plus X degree will be equal to 180 degree. Why so? Due to theorem 6.7. Clear? Now we can find X very easily. 130 degree plus X is equals to 180 degree. X is equals to 180 degree minus 130 degree. Now 180 degree minus 130 degree is 50 degree. So we have found X. Clearly we have applied theorem 6.7. Now we have to find Y. Now you can see that Y is in this triangle and there is no linear pair, of course, because it's not a linear pair, there is no line. So the third angle is not given and also Y is not given, so we cannot select QSP triangle. So we will now use 6.8 theorem. How? Now omit the line QT and PQ. So you will be left with triangle PSR and this extension SQ. So we will be applying theorem 6.8. How? We will equalize angle Y to sum of 30 and X, because it is what 6.8 theorem is stating, that external angle will be equal to sum of the two opposite internal angles. Also in triangle PSR, Y is equals to 30 degree plus X degree. Why? Due to theorem 6.8. It's very easy to understand. Just omit the line QT and PQ and then imagine the figure again. Then you will be able to find Y for sure by applying theorem 6.8. Now Y is equals to 30 plus X. We have found X already, so it will be 30 degree plus 50 degree, and as an answer we will get 80 degree. Okay, so the value of Y is 80 degree. So now you have understood that how we have applied 6.7 theorem and 6.8 theorem very easily and conveniently in order to get the unknown values, that is X and Y. Clear? Now we'll be moving to example 8, which is last example of this chapter.